Hello guys, this is Mr. Sampson. Hey, we're going to do lesson 2.6 here, Big Ideas, course 3, talking about perimeter and areas of similar figures, okay? So perimeter and area of similar figures. So perimeter, let's start with perimeter of similar figures. So let's zoom in here. Perimeter of similar figures. When two figures are similar, the ratio of their perimeters is equal to the ratio of their corresponding sides. So what does that mean? Well, if I have side AB, what side does side AB go with? So I'm going to let me zoom in here a little bit, change this up. Side AB right here goes with what side? Side DE, right? So that should go side DE, okay? That ratio of red to blue or small to big, that ratio is going to be the same as the ratio of the other side. So let's say I change this to blue. BC, right, in red, BC is going to go with EF, right? So let's find out. Yep, BC goes with EF, yes. And then the last one, let's pick a purple color. Okay, right here in purple, AC and DF should go together. So the ratio of whatever AC is over the ratio of DF, which is right there, should be the same. Okay, so they should come out the same. All right, so let's go look at an example right here. First example, example 1, finding ratios of perimeters. Find the ratio of red to blue of the perimeters of the similar figures, okay? So as you can see right here, the red side right here and the red side right here, they are corresponding sides. And this is 4 and this is 6. So we're going red to blue, so it's going to be red over blue. So if I write that down and I zoom in here, that's going to give me 4 to 6. So the ratio is 4 to 6. Okay, now what are we trying to do here? We're trying to find, what are we trying to find? We're trying to find the ratio of the blue to the similar. What's the ratio of the perimeter, right? We don't actually know what the rest of these sides are. We know that this is 4 right here, and that this is 6 right here because it's just a rectangle. But we don't know what the other side is. But it doesn't matter because we know the ratio of the corresponding sides. It doesn't matter that we don't know this other base side right here or right here. Okay, so all we know is that 4 over 6 reduces down to 2/3. So, and it's not asking us what the specific measurement of the two rectangles are. It's just asking us what's the ratio. Well, the ratio should be right here. Should be 4/6 reduced down. You divide by 2. So you divide by 2, divide by 2. You get 2/3 right there. And then you get the ratio right here, which is, 2 to 3. All right, so ratio is 2 to 3. Let's do this little example. The height of figure A is 9 feet. The height of a similar figure, B, is 15 feet. What is the ratio? So just really quickly, just draw like a rectangle. Draw a small rectangle and draw a big rectangle, okay? And we're going to say that they're similar. This is going to be rectangular figure A. This will be figure B. This will be 9 feet, and this side will be 15 feet, okay? So what's the ratio of the perimeters? Really pretty easy. The ratio is going to be 9 over 15. However, 9 over 15 does reduce. It can be divided by 3 and divided by 3. 3 into 9, 3, 6, 9, 12, 15, 18, 21. All right, so 9 divided by 3 is 3. And 15 divided by 3 is 5, so you get 3/5. So the answer is 3/5. Okay. All right, now it gets a little trickier. So the ratio of perimeter is equal to the ratio of the corresponding sides. That's pretty simple. However, now we're going to talk about area. And as I said in class, area is always squared, right? It's squared. And I've also heard it called area squarea. So I know it sounds cheesy, but it's a way to remember. Area squarea. So here we go. We're going to figure this out, and here's what it means. The area of similar figures. When two figures are similar, the ratio of their areas is equal to the square. Highlight that right there. The square of the ratios of the corresponding sides. So over here, you had the perimeter is equal to the ratio of the sides, right? So this was 4/6, right? It comes out 2/3, and the perimeter, ratios are fractions, and fractions are division. The ratio of the perimeter was the same, 2/3. Now it's not going to be the same. Now it's going to be the ratio squared, because area is always squared. All right, so I want you to look right here. You've got AB, okay, and on the other one, so that's AB right here. And on the other one, you got DE, so that is right here. Well, it's the ratio of AB to the it's the ratio of AB over DE, but then squared or squared, okay? So whatever the ratio is, let's say that this was 1, and let's say that this was 2. It would be 1 over 2, but then you square the whole thing, okay? Well, when you square it, you would get 1 squared, which is 1 times 1, which is 1. You'd get 2 squared, which is 2 times 2, which is 4. So the ratio of the square, the ratio of the areas, right, would be 1/4 if you're dealing with real numbers. Okay, let's go back to purple here for a second. Okay, BC goes with EF, right? So that should be right here. Yep, BC and EF. And then the last one, let's go, what color? Brown, okay? Brown right here, AC and DF go together, so it should be AC over DF. Now, notice you're going small to big, and small to big, and small over big, small over big, small over big, smaller over big. Okay, you got to keep the same pattern. You got to keep the same ratio. All right. Example 2. So remember this. You've got to square stuff, okay? Area squarea. All right. So let's look at our 2 triangles right here. Our 2 triangles, this side is 6, and it corresponds with this side, which is 10. So if we write that down, that gives us 6 over 10. Well, 6 over 10 reduces, because it's divisible. They're both divisible by 2. So that should give me 3 over 5. Yes. However, we have to square them, okay? So that means it's going to be 3 squared and 5 squared, which gives me 9 and 25, right? Don't forget, 3 times 3, right, is 3 squared. That's 9. And 5 times 5, 5 times 5 is 25. That's where this comes from, okay? So it's 9/25. So the ratio of the area, not just the area, but the ratio of the area is 9/25, and that's your answer. All right, we're gonna go back. I'm gonna blot out this triangle. We're gonna use these triangles again, okay? So I'm gonna get rid of this, and we're going to do this example. So let's pretend we have two new triangles, okay? All right. The base of triangle P, so let's make this P. Let's change this back to there. This is triangle P, and this is going to be triangle Q, okay? The base, oh, no, we got to go smaller. Sorry, switch it. My bad. So this will be Q because it's smaller. This will be P. The base of triangle P is 8 meters. That's right here, 8 meters. The base of a similar triangle Q is 7 meters. So they're both corresponding sides. This side and this side are corresponding. What is the ratio of P to Q? So you've got to go big to small. Well, if we write that out, that's going to be 8 That's big. Small is 7, so it'd be 8 to 7. Now, 8 over 7 does not reduce. I know that 8 over 7 is an improper fraction. However, it's asking for a ratio. Ratios are okay to leave as an improper fraction. It's okay. So the ratio of the, oh wait, no, I'm sorry. I forgot something. My bad. Area is always squared. Forgot about the R. Forgot about the squared. Area, squarea. So that means we got to square the 8. That's 8 times 8. And the 7. That's 7 times 7. 8 times 8 is 64. 7 times 7 is 49. And that does not reduce. 64 over 49 does not reduce. So that would be your answer, 64 over 49. All right, let's get to a little tougher here. Example 3. Using proportions to find perimeters and areas. All right, so here we have in our example, we have a swimming pool and we have a tennis court. So the swimming pool is right here. Tennis court is right here, okay? All right. Now, swimming pool is similar in shape to the volleyball court. They're similar, they're both rectangles. Find the perimeter P and then find the area A of the pool. So we're gonna find the perimeter of the pool and then we got to find the area of the pool. Area is everything on the inside. And area is always squared. So your area is going to be squared for your answer. All right, let's go look at the first one. Let's look at the perimeter. Now, what are they giving us? Right here, let's go green. They're giving us the area, right? They're giving us the area of the tennis court, okay? And that's 200 yards. They're also giving us the perimeter of the tennis court. That's 60 yards, okay? So the perimeter of the tennis court is, well, we know that like this right here, let's go black. If this is 10, then this is 10, right? And then we could actually find the other sides because we know that it's 60. So we take 20, take 10 away, take 10 away, it would give us 40, and then you cut it in half and it's gonna give us 20. You know it's going to be 20 because you cut it in half. It's going to be 20. If that adds up, does that add up to 60? Yes, it does. Okay? So that adds up to 60. So we know that's what that is. But that's not what we need right now. All right. So we do have the perimeter of the court. What is the perimeter of the court? It's right here at the bottom. Perimeter of the court is 60 yards. Okay? Well, if I plug that in, it should be right here. Okay, that's the width, okay? And then the perimeter of the pool should equal, okay, so let me say this again. The perimeter of the tennis court over the perimeter of the pool, right? So what are we talking about here? The perimeter, the whole outside of the tennis court over or divided by, because fractions are division, divided by the perimeter of the pool should equal the width of the court and the width of the pool. Well, what's the width of the court and width of the pool? I don't understand, Mr. Sampson. Let me show you. The width of the court is right here. It's the 10 yards. And the width of that's this. And the width of the pool is 18 yards. That's this right here. Right? Does that make sense? So we can use those numbers. All right, so the width of the court is 10. It should be 10. Hold on, let's go back. Should be 10 right there. And the width of the pool should be 18. That's right there. Okay, now the perimeter of the court is they're giving it to us. They're giving us the perimeter of the court. The perimeter of the court is right here. That is 60. Well, what are they not giving us? They're not giving us the perimeter of the pool. That's what we're trying to find right now. Well, what is that? That's going to be the P for perimeter of the pool. So the perimeter of the pool, I'm going to do this in red. The perimeter of the pool is right here. This is the perimeter of the pool in red, right there, okay? So now we can just solve and cross multiply and solve, right? However, before you do that, how about we reduce the 10 and the 18. You can always reduce fractions. Make it smaller, make it easier. This is 5 because 18 and 10 are divisible by 2. 10 divided by 2 is 5. 18 divided by 2 is 9. You get 5/9. That's going to make it easier, okay? So that should be, hold on, let's go back. If I cross multiply now, I'm going to cross multiply up, okay? And I'm going to cross multiply up. Okay, 60 times 9 is 540. Well, we changed it up, okay? So let's go back. We reduced. So I'll write it in myself. 540 goes right here. 5 times p is 5p, okay? What do we do from there? Well, that's easy. We just scale line, divide by 5 on one side, divide by 5 on the other side, step line. 540 divided by 5 is 108. Okay, 108. So what do we get? The perimeter of the pool. What were we looking for? We were looking for the perimeter of the pool. The perimeter of the pool right here was 108 yards. And you want to put yards because it says everything's in yards on this problem. All right, so right here, the perimeter of the pool was 600. Oh, wait, hold on. Oh, that's the side length. Okay, so the perimeter of the pool. Oh, no, I'm sorry. Come back. I'm like, hello. Perimeter of the pool is right here. Good Lord, I'm misreading it. It's right there, 108, just like we got 108, and 108. I'm losing my mind. All right, so that is the perimeter. We just used the perimeter. We used the 10 right here. We used 10 to 18, right, equals the 60 right here to the P, okay? That's what this was, okay? So now let's go find the area. Now, area is always squared. Area, squarea. So we've got to use the area. Well, they're giving us the area of the court. Let's go back. Let's get this out of the way. Get rid of the perimeter here. We can kind of clear this out. Okay? All right. The area, they are giving us the area is 200 yards. Squared, because area is always squared. Okay? So let's go set this up. We're going to still use the 10 right back here. We're still going to use the 10. Come on. We're still going to use the 10 and the 18. That's going to go right here, 10 and 18, okay? But it is going to be squared, right? It's squared because area is always squared, and you're talking about the ratio is squared. So here we go. Area of the court, right? Area of the court with the area, I'm sorry. Hold on, let's go back here. The area of the court, which they're giving us. What is the area of the court? The area of the court is 200 yards squared, right? Equals over the area of the pool, right? Is going to equal the width of the court, right? Which we know is 10, right here. Over the area of the court, over the width of, the width of the pool. So the width and width. We're going width and width. Are you with me? I hope you're with me. Oh my goodness. All right. Now, the one thing you got to remember, it's area, squarea. So everything's going to be squared right here. Everything is going to get squared. All right. So we're going to take the 10. We're going to take the 18. We're going to square them. We're going to take the 200 because we know the area of the court. Remember, let's go back here. They're telling us that the area of the court was 200 right here, okay? 200. So we're going to use that right back here. All right. Now, let's solve this. All right. We got to multiply. We got to square the 10 and square the 18, okay? We know that this is 200. It's going to stay 200. 200 over A, we're looking for the area of the pool. 10 squared is 100. 10 times 10. 18 squared, I don't know what it is. Let's find out. 324. All right. So we now can cross multiply, right? If we want to, we can cross multiply up and cross multiply up and get our answer. However, before we do that, let's at least you could cut the 100 in half, make it 50, right? You could cut 324 in half. It's divisible by 2. So 324, I'm doing it on my calculator, divided by 2, it's 162. That's also divisible by 2, so let's keep going. Why not? It's going to make our life easier. Divide by 2 again. Divide by 2 again. Well, that's going to be 25. 50 cut in half is 25. 162 cut in half is 81. That's going to be easier to use. Okay? So now we're just going to do 81 times 200 and 25 times A. Okay? All right. 25 times A is 25. Actually, let's go the other way. 25 times A, we go up. 25 times A is 25A. Okay? 200 times 81, 200, I'm doing it on my calculator. You can do it on your calculator. Times 81 is 16,200. However, we are going to scale line. We're going to divide by 25. Okay? If we do it to one side, we're going to divide by 25. Step line, 16,200 divided by 25 is 648. Let's see if we get the right answer. Yes, sir. 648. Oh, go back. 648. What does that mean? That means that the area of the pool is 648 square yards. Right here. Yards squared. You could write it 648 yards squared, because area is always squared. It's square yards, okay? All right. What if, let's do a what if, and then we'll be done with the notes, okay? What if the width of the pool was not 10? What if the width of the pool was 16? All right, we're going to need some rule. Find the perimeter and the area. That's going to take a minute. I'm going to go kind of quickly here, okay? If the width of the pool is 16, width of the pool is 16 and not, okay, so let's say what they're saying is instead of being 18, it's 16. We're still got 10, but it's 16, okay? So let's find out. Perimeter is going to be right here, 10 to 16 equals, what's the perimeter right here? The perimeter of the small court is 60, and we're looking for the perimeter of the pool. That's your setup. Well, reduce. This is 10. This 10 divided by 2 is 5. 16 divided by 2 is 8. That's going to make it easier. You're going to cross multiply. So let's use here we go, cross multiply up. Okay, that's going to give us 5p on this side. Equals 8 times 60 is 480, because it's 48 with a 0. 480, you're going to divide by 5, scale line. Divide by 5. Divide by 5. Step line. It's going to give you P, the perimeter. 480 divided by 5 is 96. So it should be 96 yards. And it's just straight up, because we didn't have to square anything because it was area. It wasn't area, it was perimeter. Okay, I'm going to get rid of that now, and I'm going to go find the same thing, except we're going to find the area. Okay, all right, so they're still giving us the area of the court. The pool, the side is 16, so we're going to use that again. So here we go, 10 over, I'll come back here, 10 over 16, right, equals, and we're going to square it, squared, equals the area of the pool, the area of the court, that's on top, that's 200 right here, over the area, we're going A for area of the pool. Are you with me? All right, before we do this, reduce the 10/16 again. You get 5/8. That's going to make your life easier. Now, we got to square the 5/8. So 5/8 squared, that's going to be 25 over 64 because it's 5 times 5 and 8 times 8. All right. And then over here, I still have 200 over A. All right. Now, big numbers, we're going to use our calculator. Okay. So I'm going to cross multiply. I'm going to cross multiply up. Okay. Because butterflies fly up. All right. I'm going to go back to black. 25 times A is 25A. 64 times 2 is 128, but you're going to have 2 zeros. 128 with 2 zeros, that's 12,800. All right, divide by 5. Scale line. Divide by 25, sorry. Divide by 25, we'll find out right now. Use your calculator, obviously. A equals, I'm going to do it right now, 12,800 divided by 25 is 512. So 512 square yards, because area is always squared. That is how we do it. That is how we go. Thank you so much for sticking around. I know the video is long. Have a great rest of your day. Take care, all of y'all. Be good to each other. Take care. Bye-bye.